Greetings, Kool-Aid Jammers and Team Elmo. Welcome to another exciting installment of Furlough Friday video lessons. As you can see, I'm at the beach right now. I'm not swimming in the water because there is a very strong current. Speaking of currents, that reminds me of something we've been talking about in science class, which is convection currents. So for today's sample lesson, we're just gonna review convection currents and density to make sure everyone understands that for next week. Okay, so here's what we're gonna do. Take out that worksheet that you have from Friday if you don't already, and follow along. We're gonna watch a brief video clip of convection in action, and I'm gonna try to explain through this visual how convection is working in terms of heat transfer and density. Alright, so you should all have your worksheets out right now.
Convection. You look nice and warm. Where does the heat for that hot water radiator come from? The furnace, of course. In the basement. Why is the furnace always kept in the basement? Why couldn't it be in the attic for a change? What would happen if it were? Anyone on a floor below would freeze. That's what would happen. Why is this? Well, let's put the furnace back where it belongs so that we can see how a hot water heating system works. The furnace heats the water in a tank. The hot water rises up through these pipes and into the radiators where it cools, and then the cold water flows down through these pipes and back into the tank where it is heated up again, and so on. But why does hot water go up and cold water go down? But what's all this got to do with density?
So if you'll remember, convection is the movement of heated fluid, just like I am moving on this roller coaster right now. Now, how does convection affect the way how things actually move? The answer lies in density. So if you remember from our Coke lab, that something that is less dense will rise up to the top, okay? And something that is more dense will sink back down to the bottom. Okay, so if you'll see in this demo, we have a beaker of hot water that's purple. And as you'll watch, first it started going up, but once it mixes with the cold water, it starts to sink again because it's becoming more dense. So you can actually see the convection currents because of the food coloring. All the now cold water is going to sink to the bottom because it's more dense. Right? If you rewind that clip, at first the purple liquid started going up when it was hot, but when it cooled down, it sank. We're going to review density right now to make sure we understand how this works. Whoa!
Well, the word dense comes from the Greek dasos, which means compact. So a car crusher, which turns full-size cars into compacts, is really a sort of density machine. It takes a car with a mass of, say, 2,000 kilograms and squeezes these 2,000 kilograms into a much smaller volume. So one way to increase the density of something is to keep its mass the same, but decrease its volume. You can also do it the other way around, of course. If we look at the density of the container, we see that when it holds two 2,000 kilogram cars, it's a quarter as dense as when it holds 8 2,000 kilogram cars. In this case, you increase density by keeping the volume the same, but increasing the mass.
Alright, so now let's practice using that density equation once more. Alright, so if you look at number 2, there's an example. If we have an object with a mass of 10 grams and a volume of 2 milliliters, the density would be we look at our density equation, D equals m divided by b, or density equals mass divided by volume, then we just plug in the numbers. So density equals 10 grams divided by 2 milliliters, 10 divided by 2, the answer we get is 5 grams per milliliters. Don't forget to put the units at the end, right, because that's important as well. So I'm going to let you try the next problem on your own, just like the problems we've been doing in class as review, using the density equation. Okay? So stop right now and try number 2.
Now, when water is heated, its molecules speed up and it expands and becomes less dense. And this less dense water will therefore go up, and then cool and become dense again, and therefore go down. And that's exactly how hot water heating systems work.
So this exact same process of convection is what's going on in the Earth's asthenosphere, which is this layer that we see underneath the lithosphere. So if you remember, the lithosphere is broken up into plates because we have this motion, convection, going on in the asthenosphere. The circular motion is what's causing the plates to move. And that's it. All you have to do now, answer number 3 based on what we just talked about and what you just watched. And you're done with our first ever Furlough Friday video lesson. Have a great weekend. I'll see you all on Monday. Peace.
Tectonics are the key, changing things on land and sea. Volcanoes, earthquakes and such bring up all kinds of stuff. Without crust, we'd all die. Keeps all the magma down inside. It's really cool now, don't you see? Here comes the word, now sing with